So now let's talk about solving some problems. So we've got our population of lions is 1,000, grows by 3% each year. Let's ask ourselves, how many lions will there be in 10 years? Okay? So the first thing that we want to do to solve any of these problems is to set up our equations. And we can use either. We're going to use the explicit equation here because it's a little bit easier to work with. So our explicit equation, remember we found in the last section, was P sub n equals 1,000 times 1 plus 0.03, our percentage growth rate of 3%, written as a decimal, to the n. Okay? And so if we want to know how many lions will there be in 10 years, that's P sub 10 equals 1,000 times 1.03 to the 10th. And that's very easy to solve. We can just plug that right into our calculator, and you should get, let's see, 1,000 times 1.03 to the 10th gives us 1343.9. I'm going to round that up to 1344 lions in that year. Okay? And so these problems are just this simple. Once you figure out what the equation is, you just plug in the number. Now, there are ways in which they get more complicated. So one is if it asks you when the population will hit a particular value. We're going to talk about that in the next video. But the other way that they can get more complicated is if you don't necessarily have the percentage growth rate, if you've got to figure that out. Okay, and that can be a little tricky. So let's talk about a problem like that. So let's say a town has, say, 1,500 people, and 3 years later has 1,800 people. If it's growing exponentially, how many people will it have in another 5 years? Okay? So 8 years after we started, how many people will it have? Okay? So the trick here is that we have to figure out what the growth rate is. And that's not as easy as it was with linear growth. So with linear growth, 3 years, we grow by 300 people, so we're growing by 100 people each year, right? But it's not quite as simple with exponential growth. You can't just look at this and say, 3 years, 300, we're growing by, I don't know, some percentage. It's not quite that simple, okay? So don't assume that it is. What we need to think about is we do know our initial value, P sub 0 equals 1,500, okay? And so we know that our equation, P sub n, is going to be 1,500 times 1 plus r to the n, okay? Now, the trick is we don't know what r is, and that's what we have to find. And the easiest way to do that is to use our other point. So we know after 3 years, when n equals 3, we're going to have 1,800. So P sub 3 is equal to 1,800. So 1,800 is equal to 1,500 times 1 plus r to the third power, right? Because n equals 3, then we get 1,800 as our value, okay? And this we can actually solve. Now the algebra is a little bit trickier than it was, like I said, with the linear. It's not quite as simple. We have to be a little bit careful. First thing we want to do here is divide out by 1,500, get the exponential piece by itself. So 1800 divided by 1500. 1800 divided by 1500 is 1.2. So if I divide both sides by 1500, I get 1.2 equals 1 plus r to the third. And then the next thing that I need to do is I need to get rid of this third power. So this is a little bit tricky. It's something maybe you haven't seen before. What we need to do is take the third root, okay? So what we're going to do, just like taking a square root, you would write the root symbol and then the third root of this, same way, root symbol and the third root of that. And what that's going to do is it's going to get rid of this 3 in the power. So this side is now just going to be 1 plus r. Now, you need to plug 1.2, the third root of that, into your calculator. Every calculator does this slightly differently. You can look for a symbol that looks like this. It might look like something like this, an x and a square root sign and a y. That might be the way you do it. The other way you can do it is by taking whatever number is inside the root sign, 1.2, then that caret symbol, raising it to a power. And rather than raising it to the third power like we do over here, you're going to raise it to the 1/3 power. So if you raise something to the 1 over n power, that undoes. It does the nth root. So like 1/2 would be the square root, 1/3 would be the third root, 1/10 would be the 10th root. And so that's probably the best way to do it on any calculator. So if you do this, the third root of 1.2, so let's do 1.2 to the 1/3 power. So that's how I do it on my calculator. You get 1.062 659 equals 1 plus r. And if you subtract 1 from that, you're going to get r equals 0.062659. Okay? So in this case, our r is 6.2659%. Now notice here that I kept a lot of decimal places, and that's on purpose. With exponential growth, if you don't keep all these decimal places, you can get yourself in a lot of trouble really fast. Okay? So what this gives us is an explicit equation. So let me just write down the explicit equation. P sub n equals 1500 times 1 plus 0.062659 to the nth power. Okay? And if you plug in P sub 3, so 1500 times 1 plus 0.062659 to the third power, that's going to give you, let's do this, so 1500 times 1.06269 to the third power gives you 1500. I typed in the wrong thing. So that gives you 1800.002. So this gets you very close to the value that you actually wanted. If instead, say I had rounded this and I said, oh, okay, well, let's just do r equals 0.06. Well, then P sub 3 would be equal to 1500 times 1 plus 0.06 to the third power, which is 1786.52. Okay? So you can see, even just in the first 3 years, we're off by quite a bit if we round that R value. So you want to keep a lot of decimal places. I would usually keep like 4 or 5 numbers at least. That's a good rule of thumb. But the more you can keep, the better. If you can keep them all, that's even better. Okay? So if we want to get our final answer, how many more will we have 5 years after that? So 3 years after we had 1800, another 5 years is going to be P sub 8. Okay? And so P sub 8 would be 1500 times 1 plus 0.062659 to the 8th. And that is 2659 to the 8th. Gives us a population of 2439. And notice I rounded at the end. At the end, you can round as much as you want, right? Just don't round before. If you had done this with 0.06 as your R, 1500 times 1 plus 0.06 to the 8th, you would get an error that's off by quite a bit. An answer of 2390, 2391. Okay? And so you can see here your answer, your final answer is off by 50 people, right? So it's off by quite a bit. And that's because exponential growth kind of enhances these very small errors and makes them much, much larger. Okay? So make sure you don't round before you finish the problem. Okay? In our next lecture, we're going to talk about how to solve for n. If we want to know, for example, in this problem, when will the population hit 2,000 people? And for that, we're going to need to use logarithms. And we'll do that in the next one.